Texas Success Initiative. This is the TSI assessment, and we're going to look at some sample math questions in geometry. So, let's begin with number 1. Given the two complementary angles n and 2n plus 3, find the value of n. Okay, so if they're complementary, that means that together they equal 90 degrees. So all we need to do is set up an equation. We'll say this one plus this one, because these are the two angles, this one n and this one 2n plus 3, together equal 90 degrees. So we'll say n plus 2n plus 3 equals 90. And now we just solve it like a normal algebra problem. We're going to combine these two n's. 3n plus 3 equals 90. Subtract 3 from both sides. So 3n, these of course cancel out, equals 87. Then we divide by 3, n equals 29. So that's what we're looking for, the value of n. Good. All right, so we found n. There's number 1. Okay, number 2. Given the figure at right, find the sum of angles 1, 2, and 3. So this is a transversal going through two parallel lines. So if this is a line right here, so what we can do is say 40 and angle 2 equal 180 together, because there's always 180 degrees in one straight line. So 180 minus this 40 piece leaves 140 for angle 2. Now, just as a review of terms, angle 2 and angle 3 are corresponding angles. That means that they're the same. So we can go ahead and call this one 140. And 40 and this angle right here are also corresponding. So this angle is also 40. Now, angle 2 and angle 1 are called alternate interior angles. They're on alternate sides of the transversal inside the two parallel lines. So alternate interior angles, and they are also the same. So this is also 140 degrees. So we're going to add angle 2, angle 1, and angle 3, which all happen to be 140 degrees. And if we were to continue labeling here, this angle right here also shares a line with the 40 degrees, so this would also be 140. So you can see how they are, these are vertical angles here, and then another pair of vertical angles here, so 140, 140, 140, 140, and then these would be 40, 40, 40, 40, because they always have to add up to 180 in a line. Zoom in really quick so you can see this a little better. Okay. So, quick review. We started off with 40. We found that angle 2 must be 140 degrees because they share a line together. All of this must equal 180. So 140 plus 40 equals 180. Now if this is 140, angle 2 and angle 3 are corresponding angles, so angle 3 is also 140. And angle 1 and angle 3 are vertical angles, so they are the same. So this one's also 140. But you can also find it because 1 and 2 are alternate interior angles. So just a quick review there. So we have 140 times 3. So our total here is 420 degrees. So 140 times 3 equals 420. All right, number 3. The figure below has what kind of congruence? So let's take a look at these two triangles. So we can see here, these are marked congruent, this angle and this angle, because they are vertical angles. So they are the same. Vertical angles are always the same. So they have those in common. And then they also have this side is congruent to this side, and this side is congruent to this side. So if we start at one point of congruency, so we're going to start on the single line congruency here. They have a side, an angle, and a side in common. So you always have to go in the same order. So side, angle, side. And you have to start with the same corresponding congruency. So we couldn't start with the 2 and the 1 here. Have to start with the 1 congruency with the 1, the same congruent sides, and then follow the pattern. So side, angle, side. So this has, like I said, side, angle, side congruence. And now we're going to name the angles that are congruent. So AB is congruent to. So AB is right here, and that one is congruent to CE, as we've noted there. So this is congruent to CE. Oh, I'm sorry, I labeled that wrong. My bad. AB is here. I'm looking at BC. Sorry about that. Okay, so AB. Now this one doesn't have any congruency markings on it, so we're going to match it to the other one that doesn't have any. So apologize for that. This is DE. So AB is congruent to DE or ED. Either way, labeling it is fine. Okay. Now AC, that's this one here, is going to be congruent. This one has the pair, so we're going to make it congruent to the other pair. So that's going to be CD. Right here, CD. Okay. BC. Okay, so now that's the one I accidentally marked in the beginning. So that's this one here, and that's congruent to CE. All right, now let's look at angles inside. So angle ABC. So angle ABC is going to be this angle right here. That one is going to be congruent to the other one between the green and the purple. So that's this one and this one. That's here. So that's DEC. Angle DEC. All right. Angle BAC. So BAC, that's this angle right here. And that's going to be the same one that's the congruent angle is going to be between the green and the orange. So the green and the orange, that's here. So that is angle EDC. Angle EDC. So BAC starts between the green and the purple. This one starts between the green and the purple. EDC. So you have to keep the same kind of pattern going here. Okay, last one. BCA. So BCA, this was the original congruent one we looked at, and we know it's congruent to this one right here because they're vertical angles. So BCA is congruent to ECD. So we started up here, BCA between the green and the purple, and went down purple and orange. So we start between the green and the purple, and we go to the purple and orange. So that's how we know we're going in this direction. Okay, good. So we've named all the congruent parts. All right, number 4. Given line segment AB with the midpoint at C. Okay, so let's go ahead and write this out. So we have this line segment here has a midpoint at C. So we know that this and this are congruent. So B. Okay. Point D such that BC equals BD. Okay. So if BC here equals BD, these two are congruent and they both equal 5. So now if this one is equal to 5, then so is this one, because these two are congruent. So we can see that the length of AD, they're asking here, this is going to be 5, 5, 5. 5 times 3 equals 15. And the units are in centimeters. So 15 centimeters. Okay. Number 5. Given ABC below, let's get this up a little bit. The perimeter of ABC is 22. AC is 10. Okay, so we have our base here is 10. What is the length of altitude BD? Okay, so we want this height right here. So what we're going to do is just use Pythagorean Theorem. So if this whole length is 10, this is 40 and 40. We know these two are the same. So we can split this into 5s. So we're looking for this one. We don't know what this one is. And if we recall, the perimeter is 22. So I'm going to say 22 minus the base of 10 leaves 12 to be split here. And as we can see, this is a 40 and 40, so this is an isosceles. So that tells me that these two sides are the same, and they have to be split to make 12. So this must be 6, this must be 6. So 6 plus 6 is 12, 12 plus 10 is 22. So we know we're good there. So now we can go ahead and do Pythagorean. So if you recall, the Pythagorean theorem is a squared plus b squared equals c squared. C always being the longest side, the hypotenuse. So that's going to be here. So I'm going to go ahead and call 5a. So 5 is 5 squared plus b squared. We don't know that that is. And you can do either one here. A or B can be switched. It doesn't matter. It's long as the longest side is c. Okay. So 5 squared plus b squared, we don't know what that is. That's what our goal here is to find BD, equals 6 squared. So that's 25 plus b squared equals 36. And then we subtract 25 because we want to solve for b squared. So b squared equals 11. So then we just take the square root. So our answer can be square root 11, or it comes out to 3.32, and this is centimeters. So either one of those answers should be fine. And good luck to you continuing studying for the TSI.